Again, good morning, grade 10. Let's move now to the next module, which is module 1, weeks 1 to 2 of fourth quarter. This would be the last quarter in your um, school year, right? For this quarter, weeks 1 to 2, we'll be discussing about gas laws, right? Since this topic is too long, we might limit some of the examples. At the same time, we might limiting also um, some of the not that important details. By the way, this module, I actually make it very simple for you to understand, right? All the discussions are there already. Okay, so let's move forward. Gas laws. Gas laws are examples of scientific laws. Okay? When you say scientific laws, these are statements that describe, summarize, and predict some aspects in nature. Okay? So there are two types or there are two classification of scientific ideas. We have scientific laws and scientific theories. So let's take a look at scientific laws. Scientific laws, um, we can consider it as a scientific laws if it has a strong supported by empirical evidences which are repeatedly verified with no contradicting observations. Okay? Just like the laws of motion by Newton. What else? The the gravitational law. So those are just few examples of those which don't have contradicting observations. Second can be mathematically formulated in one or several statements or equations. Third one are constant because they summarize what have been observed. Okay? Laws are different from theories. Okay? A scientific theory is a well substantiated explanation of some aspect of natural world based on the body of facts that have been repeatedly confirmed through observation and experiment. Scientific theory may alter or evolve if new evidences are discovered, just like the theory of relativity by Einstein. So, the theory of relativity by Einstein still until now it's evolving. Okay? Until it will become a law. Question so far? Grade
Yeah,
10?
so far.
Alright, so let's move forward. Boyle's law. Okay, pressure and volume. The proponent for Boyle's law is Robert Boyle, who studied the effects of pressure to the volume of gas in the sealed end of the tube by adding a mercury on the open end. Okay? Just like your thermometer with mercury or mercurial thermometer, or other example is your mercurial blood pressure kit or your blood pressure kit. He noticed that the volume of definite quantity of a dry gas is inversely proportional to the pressure provided the temperature remain constant. Okay? 1 atm or atmospheric pressure is equal to 760 millimeter per mercury. Okay? Or is equal to, or 1 atm is equal to 760 torr, named after Evangelista Torricelli, a 17th century Italian scientist who invented the mercury barometer. Again, 1 atm is equal to 760 millimeter per of mercury or 760 torr. The pressure volume relationship can be written as pressure is equal to 1 or pressure is inversely proportional to volume or PV is equal to C. where P is the pressure of gas expressed in millimeter of mercury or ATM or torr. V is for volume of gas expressed in millimeters or liters, and C is the constant. Sure, how could that be possible? How can you formulate that formula? Okay, so in formulating this formula, we need to consider the constant. Okay, the pressure volume relationship is pressure is inversely proportional with the volume. So that is why we need to consider the constant. So we need to move the pressure to the next side or to the other side to make PV is equal to C or C is equal to PV. Still the same. The equation states that the product of pressure and volume is constant for a given mass as long as the temperature is constant. Take note, as long as the temperature is constant. Okay? In comparing same substance under two different sets of conditions, the law can be expressed as P1 times PV or PV1 is equal to P2 or pressure 2 times V2 or volume 2. We're in P1 is equal to the original pressure, volume 1 is equal to original volume, and pressure 2 is equal to the new pressure, and volume 2 is equal to the new volume. Okay. We are still in the Boyle's law. The kinetic molecular theory explained that the inverse relationship between pressure and volume, if the same amount of gas at the same temperature is confined in the smaller volume, the gas molecules become crowded and collide more frequently against the wall of the containing vessel, causing the increase of pressure. How can you create pressure, by the way? Based on the kinetic molecular theory, this explains that there is an inverse relationship between pressure and volume. Okay? Now, if the same amount of gas now and the temperature is confined in a smaller volume, the gas molecules becomes crowded. Okay? And collide more frequently against the wall of the containing vessel. Just like when you um, have you tried using a syringe, grade 10?
Yes.
If you're going to cover the tip of the syringe, you remove the needle, you need to cover the tip of the syringe, and you push, you gather first air in the syringe, and you cover the tip of the syringe, and you push, you put some pressure in it. Tendency is the air inside will bump to each other. They will become crowded and collide more frequently. So you are now creating an increase in pressure. So that is actually the one being explained by the kinetic molecular theory. Okay, let's move forward. Do you have any questions so far? Questions?
None so far.
All right, so let's move forward. Gas molecules are constantly moving in all directions, thereby creating impact on the sides of the container. The impact force per unit is called pressure. So you are now creating pressure. Okay, just like this one. So this is one of the example of um, creating pressure. If you're going to look at it, if the smaller the container, okay, the more pressure you can create. Okay, because the molecules of gas there are being compressed, okay, making the container smaller and making the area smaller. So you are now creating pressure on it. Okay, Boyle's law explains the following phenomena or application. The bubbles exhaled by the diver increase in size as he or she approaches the surface of the ocean. The pressure exerted by the weight of the water in the bubble decrease as one goes up the surface. Hence, the size of the bubble increases. Correct. Okay. Deep sea fishes die when they are brought in the surface. Why? The pressure decreases, thereby causing the volume of gas in their bodies to increase in size. This causes the membranes of their bladders and cells to pop out or to pop because these this species of fish is is used to with the high pressure. That is why if you're going to put them in the low pressure areas, tendency they will what? Their membranes and bladders and cell will pop out or damage. Just like have you heard about the news about the ores, sea ores? Ores.
Yes.
Okay. So the reason why those ores died simply because their membranes pop out. Okay, these are deep sea creatures, and usually they come out in the low areas for the reason that their habitat is being destroyed. Number one, number two, it could be that there is a disturbance in their habitat. That is why. If or there are some movements in the seafloor that disturb them and goes up. That's the reason. Yes. Okay. Correct, Trisha. Some whales also uh, die because of this. Okay, because of the pressure. These whales are used to with high pressures. Okay, the more deeper you are, the higher the pressure you are into. That is why submarines needs to have a brilliant atmospheric pressure before going into the deep sea. Any other question? This is really interesting. You know what? This topic gas loss is really interesting simply because you can actually observe this one anywhere you go. No? It's a matter of observation. Science is a matter of observation. Once you observe something, and you tend to relate it with certain topics or scientific ideas, tendency is you will be analyzing all of this data, you'll be internalizing, and this is now the what? The application. Okay? We still gather these ideas in order for you to apply in your daily lives. That is why. That is why I make this module as easy as possible for you to internalize. Because this topic will not leave it here. Okay? You'll be bringing this one until senior high and college. And this is really interesting. An inflated balloon burst if squeezed too hard. Squeezing reduces the volume of the balloon, thus increasing pressure. If the balloon cannot withstand the pressure, it bursts. Correct. Okay, when you squeeze the balloon, you are now creating pressure. The one that I used a while ago with the example, syringe is used to drawing blood sample or giving injection. If the plunger of the syringe is pulled out back, the volume of the syringe is increased and the pressure inside is decreased. To balance the effect of low pressure, air or blood is sucked through the needle. This is to equalize the pressure inside and outside the syringe. Or this is now the state of equilibrium. Okay? When you say state of equilibrium, the pressure inside and the pressure outside is equal. So there is no movement. But if there is an equal concentration or an equal um, pressure inside and outside, there is a movement. Okay? From greater concentration to lesser concentration. This is to make equilibrium or equal pressures inside and outside. Ears pop at high altitude. This is common. Most of the time, you feel pain in your ear while an increasing or descending a plane. No, when you're riding a plane, when the plane goes up high in higher altitude, your ears pop. In these situations, there is a pressure imbalance. Remember that the pressure there is from greater concentration to lesser concentration. Okay? There is an imbalance inside and outside your ears, increasing or decreasing volume of air inside your ear that strains the eardrum. Okay? To relieve the discomfort, swallow hard to equalize the pressure on either side of the eardrum. Okay? Have you tried this one?
Yeah.
Even going to mountainous provinces? Busay, going to Busay. Okay? You can experience this one. Even riding an airplane, no? Yes, correct, Trisha. Chewing a gum will actually equalize the pressure. Or swallowing hard. It will equalize the pressure. So this is observable, no? Just what I had told you a while ago, that scientific ideas is highly observable. This is based on what they had observed. And we tend to just ignore those things, but those are scientific ideas. And you will learn something out of those. Let's go back first to Boyle's Law. Some of the examples for Boyle's Law is, let's have this example first. Just give me a minute. Let's have this example first. Let's have this. A 45 ml gas exerts a pressure of 760 millimeter of mercury, what is the volume of the same gas if the pressure is increased to 800, okay, millimeter of mercury at the same temperature? Okay, so the for in answering scientific problems, we need first to identify the what are the given. Okay, the given are volume 1 is equal to 45 ml. Okay, pressure 1 or P1 is equal to 760 millimeter of mercury, and we are looking at the volume 2. This is the unknown, and the pressure 2 is 800 millimeter of mercury. So we already identified the given. Now let's get the base formula. Okay. So solution. The base formula is P1, correct? Times V1 equal to, ay, nako, is equal to pressure 2 times volume 2. Correct? Grade 10? Are you still with me?
Yes, sure.
Okay. Let's substitute first. Okay? Since we already have the base formula, we can now substitute. Okay? P1, this is P1,
760.
760 millimeter of mercury times V1,
45 ml.
5 ml is equal to P2
V2.
is equal to P2. What is the value of
800
800?
millimeter of mercury.
Okay. Millimeter of mercury
Mercury.
times
V2 is unknown.
2 because this is unknown, right? Okay.
Yes.
Yes.
Substitute. It will be next. Okay. This is equal to
I think you should divide both sides with 800 mm or with the value of P2 so that you can cancel the P2 on the other side.
we
I
need.
don't know, it's just
Yes. I need your ideas in order for me also to gauge you on how to solve because this is a common mathematical equation. Again, mathematics and science go hand in hand. You go. I want your ideas. How can we get
um
V2 in the other side? Because the V2 is unknown there, right? So we are now formulating our own ideas based on the base formula. Okay, what should we do next?
I think you should cancel the P2 so that the V2 will remain on the other side. And then for that to happen, you have to divide the value of P2, which is 800 millimeters of mercury on both sides, and then in the right side, the 800 millimeters of mercury will be cancelled, and then on the left side, 760 millimeters of mercury times 45 ml over 800 millimeters of mercury will be will what I mean that is what we will see, or what we will solve.
Impressive. Yes, correct. What we're going to do is to multiply both sides, or divide both sides rather. So in doing that, let me illustrate it to you. So we will divide both sides by 800. Sure, what is the purpose of multiplying each sides by 800? This is to cancel out the 800 and to remain the what? V2, because we're
The
looking,
P2.
correct? So what will be happening is we will multiply. I will copy this one, ha, to have a clear illustration. I will copy this one and put it down. Okay. So we will divide. This is the hardest part of online class because okay, we will divide both sides by 800 millimeter of mercury. 800 millimeter of mercury. To cancel out 800. Okay. So, may gulay. It's really hard for me. But this is really easy when you are in the face-to-face. Okay, let me annotate. Okay. So you can now cancel the 800 there. Okay. So, what will remain next? Okay. Since you are now canceling 800, on the other side is, it remains V2. Correct? Correct?
Yes.
Okay.
Yes.
Cancel my annotation. Okay. So, this is V2 here. Oh, may gulay. Okay. And you can now substitute. Okay. You cancel also mercury. Right? Because based on calculations, or based on mathematical equations and calculations, the same, you can actually cancel the same um,
Unit.
units used. Correct. So we can cancel this one also. Okay. These are just basic, right? That is why
Yeah.
science is easy, because you're just implementing, or you're just using formula. Okay. 700. Okay. Let's continue. What should be next?
We solve the 760, 45, and 800.
Yes, but don't forget the ml, because ml is not yet cancelled.
Okay. So what will be happening next? After canceling
Seven.
units and 800 on the other side, we actually extracted the V2 already, right? So the next
Yes.
thing to happen is,
Yes.
what should be next?
Solve for V2.
Solve for
Solve
V2.
for V2.
So,
Yes, by multiplying 760 by 45 ml, and then dividing it with 800.
okay, correct. So we are now following what? The rule. Okay. This is now considered as a
Yes.
MDAS. Okay. You have
Yes, the M does.
thus multiplication, okay,
And then division
division, addition, and
and
subtraction.
subtraction.
Okay, so this is the ruling of solving scientific problems. Okay, so 760 times 45, this is
34,200.
34,200.
200.
Okay, 34,000, 760 times 45, 34,200. Okay, do not forget
Yes.
the
The
ml.
ML,
ml,
the U
the unit being used, over
over 800.
800. Okay, oh my god, 800. Okay, since we don't have unit already because it is already cancelled. So
Yeah.
34,200 divided by 800,
42.75.
75.
ML.
The value of your V2 is
42.75 ml.
equal to 42.75.
75 ml.
Okay, this is now the answer to the question. What could be, what is the volume of gas if the pressure is increased to the same, to 800 millimeter of mercury at the same temperature? So the answer is the volume of gas, or the final volume of gas is 42.75 ml. Was that easy?
Yes.
Yes, sir. For now.
That is just easy. You know, it is a matter of how you internalize the problem. Okay? Well, definitely, if you have your algebra, you can just, you know, take this as easy. Let's move forward. Oh, see, we are still in the first law, but we consume a lot of time. Okay? Can you see my shared screen?
Yes.
Let's move now to,
Yes, sir.
okay, Charles law, volume and temperature. Jacques Charles duplicated the experiment done by Joseph and Etienne Montegolfier in June 4, 1783 in Annonay, France. He is actually a French. He used fire to inflate a spherical balloon about 30 feet in diameter that traveled about 1.5 miles before coming back to Earth. So this is now the birth of the hot air balloon. Okay. Charles found out that the volume of the gas is directly proportional to its absolute temperature under constant pressure. So, V is directly proportional to time, or temperature rather. Volume is directly proportional to temperature, or V over T is equal to C. Or in volume of gas may be expressed in ml or liters, and temperature is always, take note, expressed in